Hello third graders, this is Mrs. Copeland and I'm a math teacher in Charlotte-Mecklenburg Schools. I'm going to be helping you with third grade memory joggers. Let's take a look at week 9, day 4, problem B. Juan drew a hexagon with sides of different lengths. Circle the shape that could be Juan's shape. Thomas drew a parallelogram with 4 square corners and adjacent sides with different lengths. Circle the shape that could be Thomas's shape. We have several things to remember. We can describe shapes using their attributes, including the following. Are the corners square? Would the opposite sides meet or cross if they continued going? Are opposite sides the same length? Are adjacent sides the same length? How many sides does the shape have? If it has 3 sides, it's a triangle, 4 sides, quadrilateral, 5 sides, pentagon, 6 sides, hexagon, 8 sides, octagon, or 10 sides, decagon. There are several kinds of quadrilaterals. There are trapezoids that only have 1 pair of opposite sides that will never meet or cross. A parallelogram has 2 pair of opposite sides that will never meet or cross. A rectangle is a kind of parallelogram with 4 square corners. A rhombus is a kind of parallelogram with 4 sides that are the same length, and a square is a parallelogram with both 4 equal sides and 4 square corners. Okay, let's look at our first question. Juan drew a hexagon with sides of different lengths. Circle the shape that could be Juan's shape. We see that a hexagon has 6 sides. So let's find the hexagons at the top. This one has 1, 2, 3, 4, 5, 6, 7, 8 sides. That's an octagon, not a hexagon. 1, 2, 3, 4, 5, 6. That's a hexagon. 1, 2, 3, 4, 5, 6. That's a hexagon. 1, 2, 3, 4. That's a quadrilateral. It only has 4 sides. So we know it was a hexagon, and we know the sides have different lengths. This hexagon looks like it has sides that are all the same length. This hexagon has sides that are all different lengths. So this must be Juan's hexagon. Thomas drew a parallelogram with 4 square corners and adjacent sides with different lengths. Circle the shape that could be Thomas's. So which of these have square corners? Remember, square corners mean that a square will fit perfectly inside the corner of it. This one, when you see that, doesn't, but then when we go to this one, for example, it does have a square corner. Lots of times you'll see a small symbol like this in the corner to show that you could draw a square in it. This one does not have square corners. This one has square corners. This one has square corners. This one has this square corner and this square corner, but those are not square. And we need a shape that has 4 square corners. So this one cannot be it. Now our second clue is that the adjacent sides, those are the ones that are side by side, are different lengths. So when I look at this shape, I can see that this side is the same as that side, but this side is also the same as that. All 4 sides are the same. This is a square. On this one, the opposite sides are the same length, but the adjacent sides are 2 different lengths. That's a short side and a long side. So this is Thomas's shape. Thank you, and if you have additional questions about this problem, please ask your classroom teacher.